Let's look at the a two-tailed version of the correlation hypothesis test. Sometimes you don't have direct positive or negative ideas. So suppose a researcher believes that temperature is related to coffee sales, but don't know the direction of the hypothesized relationship. So he records the temperature and coffee sales for 12 randomly selected days, like that, and you get this correlational, the R value. It was minus 0.86. It's a really strong correlation, even stronger than the earlier example. So it looks like this. So we do a hypothesis testing. In this case, there's no direction, so okay. Null hypothesis would be, okay, there is no correlation, which is simply means that rho is going to be 0. That's the null hypothesis. And this alternative hypothesis is going to be rho is going to be not 0, either plus or minus, positive or negative. Okay, and let's do the same hypothesis test with this. Degree of freedom is 10, right? Because they're 12, and you have to subtract 2 from that. So you know why 2, right? Because there are 2 sets. So it's compared to just having one variable here. The amount of error is going to be bigger. So instead of subtracting 1, you're subtracting 1 for this one too. And we're doing a two-tailed test with 10 degrees of freedom, and we use an alpha level of 0.05 as usual. And so what it does is let's go back to this. Now we are using a two-tailed test, so we're gonna have to look at this, and then degree of freedom is 10, and we're gonna use the alpha level of 0.05, so it's here, and so the critical value for this hypothesis testing is 0.576. So anything beyond that is a critical region, and if the R value is bigger than this, that means it falls into the critical region, and we can say that the chances of this happening by chance as a sampling error is so small, too small, and we can conclude that the correlation was strong. So let's take a look at the example. Okay. So a critical value of R is, we have to be careful because there are two tails, so it's plus or minus 0.576, and our sample correlation was minus 0.86. So it falls in the critical region. So we have to reject the null hypothesis that there's no correlation. So there is, statistically speaking, there was correlation. That's a relationship, statistically speaking. It's not talking about the size of the relationship. I mean, we're not sure how practically important it is. That's coefficient of, what was that? Okay. Well, first of all, there's a conclusion. So the analysis indicated that the relationship between the temperature and coffee sales was significant. R equals to minus 0.86 and N equals to 12, and the P is less than 0.05 and two-tailed. And and we do R square for the coefficient of determination, and the value we get is 0.74. So 74% of the variability in one variable is explained by its relationship with the other variable. So 70% is in the correlational relationship. So that's really large correlation. If you remember the guidelines for that, was this. Anything, if it's 0.25 and above, then it means large correlation, and in our example it was 0.74, so it's a really large correlation. So we say it's a large correlation.